Hello, dear students. I am Samir Velankar. I welcome all of you to this video of binary search tree, in which we will be learning about binary tree traversal methods. Now, our aim is that we are given a binary tree. As I have drawn in red color over here, this is a binary search tree. As you can observe that less than and greater than rules are followed over here, and the values which are less than 10, that is value of root, are added to the left, and values which are greater than 10 are added to the right. So what we are given in is a binary search tree, and we want to traverse the tree. That's the word, traversal. Now by traversal we mean that we want to go to each exactly once, and maybe we want to print the node. We want to print the contents stored in every node, but we want to print the contents of each node exactly once. We don't want to visit any node more than once. That's what we call it as traversal. Like in earlier topics, we saw how to traverse a linked list. Like we saw that a doubly linked list can be traversed in two methods. You can go in a doubly linked list from first node to last node, or from last node to first node, as two-way pointers are available in doubly linked list. Now our aim is just to print the tree, just to traverse the tree and print all this data. There are three ways in which you can traverse a tree: in order, pre-order, post-order. All these three methods are called traversal methods of binary search tree. Now let's see one by one on the tree which is given here, the sample tree which is given. We will see what will be the outputs, and while tracing in order, pre-order, post-order on this tree, at that time itself we will learn the technique behind these three traversals. The first one, the in order, uses a rule called LVR, where L means left, V means vertex, and R means right. Left, vertex, right is the order in which the nodes are visited and printed. Now, to understand this in somewhat a easier way, I am drawing a very small tree on the top of the page. Let's imagine we have only three nodes, 10, and the left of 10 is 5, it should be less than 10 because it's a binary search tree, and the right of 10, let's assume, is 20, greater than 10. All other pointers that I am showing are null, and root is pointing to the topmost node 10. Now, if at all we are supposed to print this tree in order traversal, then the rule states that you should print left branch first, or left subtree first. Then you should print vertex, and finally you should print right subtree. So if you are talking about any node, first you should print left branch of that node, then you can print the node, and finally you can print the right child. Now over here you can see that 10, which I am marking right now, 10 can be printed only after printing its left child, isn't it? Because the rule states that you cannot print 10 before printing the left. LVR is the rule. Left, then vertex, then right. So before we print 10, we should print 5. And you notice 5 does not have followers. It has nothing beneath it. So the first value printed will be 5. Now as you have printed the left child of 10, you are now free to print 10. So that is vertex is now getting printed. After printing the vertex, you can print the right child. The right child of 10 is 20. So 20 gets printed. So in a simple definition, I can label this 5 as the left branch of 10, 20 as the right branch of 10, and 10 itself can be called as vertex. So the order in which in order will print this tree is left, that is 5, then vertex, that is 10, and then the right, that is 20. All right. Now, I'm sure through this short explanation, everybody has understood what do I call as left and right. It is very easy, left child and right child. But there can be a slight confusion about what do you mean by vertex. Now, the sentence which I am telling is so helpful that you never forget this sentence. What is vertex? I'm trying to explain that. Now, when we will traverse this tree, when at the time of traversal, definitely we will go to some node. Then again we will go to some other node because we are traversing it. Now, what is vertex exactly is whenever we reach any node for the first time, then we call it as a vertex. Suppose I go to 20 and I have been to 20 for the first time now, then 20 is my vertex. So I repeat, what is vertex? While traversing the tree, when we reach any node for the first time, we say that okay, I am at 10 for the first time, then 10 will be called as vertex. Remember this, and the traversals, believe me, in order, pre order, post order, will be fun. It will be absolutely no problem whatsoever. You can orally find out without even using pen and paper. So let's see what is in order. The rule states LVR. Okay. So first print the left child or left branch, then print vertex, and finally print right branch. Let us start in order on this tree. So from where will you start the process? Yes, I am asking you a question. Just try to answer it. From where will you start the traversal process? Your answer should be, and I am sure it was, you should start traversal from the root node. Why? Because that's the only node you know. You don't know anybody else address. You just cannot jump to 5 directly and say, I will start the process from 5. Hello, to reach 5, you will have to first go to 10 and 10 will tell you where is 5 by using this left pointer. I hope you are understanding. You just can't start the process from 20. You can't say, I will start traversal from 20 because to reach 20, you will have to first reach 10 because 10 has the address of 20 in the right pointer. I hope you are understanding. So from where will in order traversal begin? It will begin from root node. So let's go to 10. But hello, we are at 10 for the first time, isn't it? Yes, we have reached 10 for the first time. Then can we print it? Now listen, whenever we reach any node for the first time, we will call it as vertex. And what does the rule state? You can't print the vertex. Before printing the vertex, check this. You have to print the left child of that vertex. So what we do is, we leave aside 10, okay, and we visit the left child. Left child is 5. So we are at 5 now. But aren't we at 5 for the first time? Then you will call 5 as the vertex. And the rule states that you cannot print vertex yet because left child of the vertex, LVR is the rule. Left child of the vertex must be printed. So you leave aside 5 and you visit left child of 5, which is 2. So we are at 2 for the first time. We are at this node for the first time. Can we print it? No. Before we print the vertex, we should first attempt to print the left child because the rule is LVR. But you notice left child of 2 is null. There is nothing to the left of 2. Hence, we can say that we have finished with left child of 2. So we can now print 2. Vertex can be printed. So the first value that will be printed due to this tree in order will be 2. Okay, let's recap very fast. We started from 10, that is root. But this was vertex because we were here for the first time. So we said, no, we can't print vertex. We have to first print left. LVR is the rule. So we went to left and this again become a new vertex because we have reached 5 for the first time. So we said we can't print 5, we should first print 2, the left child. When we went to 2, we said it is our new vertex. But before printing it, we should print the left child. But left child was not there. So L, the left, for this 2 is over. So LVR is the rule. So we printed the vertex. Now what? After printing LV left vertex, we should deal with right. But observe, right child of 2 is also null. That means we have finished our process completely with this node 2. Okay, what we have finished with node 2? Remember, with node 2, we have finished L, then V, then R. So we say in order process for 2 is over. So now we backtrack, once this 2 is over, we backtrack to the node from where we came to 2. You recall from where did we come to 2? We came to 2 from 5. So we will go back to 5. Okay. And when we are back at 5, we see that left of 5 is over. Whatever is to the left of 5, what was there to the left of 5? 2, it has been printed. So now we can print the vertex because the rule is first print the left child, then print the vertex. And the left child has been done. So when you are back at 5, you can print 5. I hope you are following the video properly. Now, after printing 5, that is vertex, we should visit right. Observe the cursor L, V, R. So now we are at new vertex. 8 is our new vertex. But then can we print it? No, not yet. First, take the left child, but left child is null. Okay, that means left of 8 is already done. It is null. Now you can print the vertex. So 8 gets printed. After the vertex, we should visit right, but the right child of 8 is also vacant. So what have you finished for 8? For 8, we have finished visiting left child. Left child was null. Then we printed 8 and visiting right child. So we declare process of LVR, left vertex right, for node 8 is over. Once this node is over, we backtrack. We will backtrack exactly to the node from where we came to 8. We came to 8 via 5. So we are back at 5. When we are back at 5, we check that there is no process for 5 pending because left, that is 2, was done. 5 itself was printed and right of 5, that is 8, was also done. So L, V, R for 5 is done. As 5 is also over, we will backtrack to 10 because we came to 5 from 10. And you recall last time we did not print 10. In fact, the process started from 10, but we did not print 10 because left of 10 was pending. Now I think you have understood what do you mean by L in LVR. The left of 10, by the way, over here means the entire left branch of 10. Whatever is to the left of 10 has been printed, isn't it? Now 10 can be printed. I hope you are following the video properly with ultimate patience. This is so interesting and important. Okay, now V is over. See, L left of 10 is over. Then V itself, that is 10, is over. Now let's visit right because LVR is the rule. When we take right branch, we are at 20 and this is our new vertex. So the rule states you must visit left first. LVR is the rule, but left is empty. So you can print the vertex. So 20 gets printed. After printing vertex, that is 20, we visit right. So 25 is our new vertex. But we should first visit left, which is null. So we are free to print the vertex, which is 25. 25 gets printed and then right of 25 is also null. Hence, the entire tree has been visited and you see the output of in order. Very interestingly, output of in order is always in increasing order. Output of in order is in increasing order, but for binary search tree. That means if lesser values are stored to the left of parent and larger values are stored to the right of parent, only then we call it as binary search tree. So for a binary search tree where less than greater than rules are preserved, in order outputs will always be in increasing order. All right, let's now see pre-order traversal. VLR is the rule. Now pre, as the name suggests, means before, isn't it? So vertex is printed before left child and right child is the most neglected child. Right child will be printed last. Also, you recall what do you mean by vertex? That's a very important statement. During traversal, whenever we reach any node for the first time, it's called vertex. Remember this. So let's start pre-order traversal on the same tree. Okay. From where shall you start the pre-order traversal? Come on, you should start from root because that's the only node you know. You don't know any other node. Using the root pointer, you can reach 10, but you can't reach any other nodes directly. So the process starts at root node, that is 10. But we have reached 10 for the first time, isn't it? So isn't that our vertex? And what does the rule state? Pre-order rule states that you can print vertex and then move left. So the conclusion is that we are at a vertex 10 and we will first print the vertex and then we will move left. Now left of 10 is 5. Remember, vertex is printed and then we visit left. So we are at 5 for the first time. So it is vertex. And the rule states you print the vertex and then visit left. So we are now going to print 5. 5 gets printed and then we visit left of 5. Now the left of 5 over here is 2. But we are at 2 again for the first time. So this is the vertex. And we have to print vertex and then move left. VLR is the rule. So we will print 2 and we will move left. But left of 2 is anyway null. So left is over. So what have you finished for 2? Remember, we have finished the vertex, we have printed the vertex, we have finished the left movement, but right is still pending. So we try to move right, but right is also null. Hence, for this node 2, we observe that we have finished all the three process: print the vertex, move left, and move right. So once 2 is over with its pre-order, look, pre-order for 2 is over. Then we will go back, we will backtrack to the node from where we came to 2. We came to 2 from 5. Yes, exactly. So we are back at 5. It's very important for you to remember what are all the things that we have already done for 5. Remember last time when we were at 5, we printed 5. That is vertex is over. And then left movement is over. So VL is over for 5. Now we will visit right. So we are at 8 and it is our new vertex. And the rule states that you first print the vertex V and then move left, but left of 8 is null. So done. And after VL, you try to move right of 8. That's also null. So for 8, we have observed that all three things VLR is over. Now we will return back or backtrack to the node from where we came to 8. We came to 8 from 5. But when you will be back at 5, you will notice that we have finished all the jobs for 5. We have printed 5, that is V is over. Then L is over, left branch, and right is over. So VLR for 5 is over. So we will backtrack to 10 because we came to 5 from 10. But when we are back at 10, you notice we have finished V and we have finished L. Last time when we were at 10, we printed 10, isn't it? Because vertex is printed and then left is taken. So now you might understand what do you mean by that L. L means print the entire left branch of 10. So we have printed vertex 10 and we have printed entire left branch of 10. Now we will visit right of 10. VLR is the rule. So now 20 is the new vertex. And the rule states we can print 20, then visit left, but left of 20 is anyway null, then visit right. So VLR, 25 is the new vertex. 25 is printed, vertex is printed first, and then left VL, but L is null, and R is also null. So that's the way how we have printed all nodes using pre-order. Just observe the output of pre-order. Output of pre-order is neither in increasing order nor in decreasing. It's just random order. But very importantly, the very first value of the pre-order traversal, this value, which was printed, is definitely value of root. So property of pre-order traversal is that first value printed in the pre-order traversal is the value of root node. Remember this. Now let's go on for post-order traversal. Let's make the things faster now. Post order, as the name suggests, post means after. Vertex is printed after everything. First the left branch, then right branch, and then the vertex. So if you start post order on this tree, it will start from 10, that is root. But when can you print 10? Only after printing all the left branch of 10 and all the right branch of 10. Listen, L, R, V is the rule. So first print left branch of 10, then print all at right branch of 10, and finally print 10. So are you understanding? 10, that is root, will be printed last in post order. Okay, let's start. Start from root, you can't print it because V should be printed last, vertex. Vertex should be printed last. So what will you do? What does the rule say? Left vertex right, LRV. So first prefer left, go to left. Can you print 5? Not really. Before printing 5, you should print left child and you should print right child, isn't it? LRV is the rule. I hope you are understanding. So leave out 5 and first visit left because LRV is the rule. When you are at 2, you can print 2 because anyway left is null and right is null. So LR is over and now you can print vertex. So the first node that gets printed due to post order is 2 here. Now you can see for 2, we have finished L, left was null. We have finished right, R was null, and we have finished printing vertex. So we will backtrack to 5 because we came to 2 via 5. We still can't print the vertex because after we have finished with left, we should finish first with right of 5. So we are at 8. And before we print 8, we should deal with left and right. But left and right, L and R are null. So L, R, V is the rule. We can print 8 because 8's left and right is anyway null. Now you observe for 8 we have finished L, R, V. So we should now go back to 5. For 5, we have finished left branch, that is 2. We have finished right branch, that is 8. Time to print the vertex. LRV, V gets printed last. So 5 gets printed. After printing 5, we will backtrack to 10. Still can't print 10 because only L is done for 10. R is still pending. So we will visit right before printing 10. We visit 20 and the rule states first visit left, then right of 20, finally print 20. But left is anyway null. So we visit right of 20. Right of 20 is 25. And 25's left and right are null. So LR is over. So we can print 25. After 25 is printed, we will backtrack to 20. And now 20 can be printed because left, right of 20, left and right of 20 is done. So vertex is printed, which is 20. After doing with 20, we will backtrack to 10 and now 10 can be printed because everything to the left of 10 and everything to the right of 10, LR, is done. So now we can be printed. That's 10. Now you observe output of post order is also neither in increasing nor in decreasing order. But very important fact is that the last value printed in the post order is always value of root. Remember this. But one very interesting thing about in order, you saw that in order is in increasing order, isn't it? You remember this also only for a binary search tree. If you are given a binary search tree, then in order will be in. All right then. So it's very easy, to remember these rules. Now, by the way, in order, pre-order, pre-order, and post-order. Now, it's very easy to remember these rules. In order, as the name suggests, in between. So, vertex is visited in between left and right. Now, pre-order, as the name suggests, pre means before. So, vertex is visited before everything. Then post order. Post means after. So vertex is visited after everything. And you might have observed in all the traversal techniques, L came before R. L was written before R. So it's only a matter of filling in the blanks. Here L comes before R. So LVR is the rule. Here V is before because pre-order means V will be visited first and L comes before R, and post order means V is after everything but L comes before. So these rules are very easy to remember. Now, that's how in order, pre order, post order are done. Similarly, we have one more example over here, a bigger example. And just note, I'm going to write the in order, pre order, post orders of these traversal techniques. And then you check it according to the explanation done above. Are you getting this output? But the in order for this tree is going to be 4, then it's 25, then it's going to be 6, then 9, then it will be 7, okay, then 10, then it will be 5, 8, 14, 3. This is the output for in order. Now you notice the output for in order over here, is not in increasing order. That's because the tree given to us was not a binary search tree. You observe, how can you have 25 to the left of 10 and 3 to the right of 10? Further, any values are added as per our wish. There is no rule less than or greater than over here. So if you are simply given a binary tree, then the in order output won't be in increasing order. All right. So what is pre-order for this? Just check. Pre-order will be 10, 25, 4, 7, 6, 9, then 3, 8, 5, and 14. And post-order traversal will be 4, then 9, 6, 7, 25, 5, 14, 8, 3, 10. You can just check on your own using the explanation I did previously that you are getting these outputs. Now, many textbooks or many other authors or teachers, teach this in order, pre order, post order by teaching some tricks. For example, they say that if you are having some tree like this is not to oppose anyone. Please try to understand. I'm just trying to guide you in the proper lines. Now they often draw some arrows like this and follow the arrows, and you will get in order. Some tricks like that. I don't understand. Some tricks like that are given. Never ever indulge in the tricks, because we are attempting gate exam, and in the gate exam we have to know intricacies in and out about in order, pre-order, post-order. So you follow the rules which I have given. You understand the definition of vertex. You properly understand the procedure of in, pre, and post. Better see this video 4 or 5 times to understand how the outputs were produced. Thank you very much.